Hi, welcome to the latest of my Python tutorials. So in this video I'm just going to show you how to do something a little bit different. We're going to use the command line arguments this time to get data into our program. We're going to work on the Fibonacci numbers again, and what I'm interested in here is just looking at the difference in trying to use an iterative function or an iterative algorithm, and using a recursive one. So okay, so the first thing I need to do in order to be able to use the command line arguments is to import sys. So then what happens is that any arguments are put into a list which is called sys.argv. So I need to check if that is more than one, has more than one argument in it. If it is, then I can put that element, which is going to actually be sys.argv1, into a variable. It's not going to be item 0 because that would be the name of the program. So then I'm going to print you passed me and the number. If by any chance the user doesn't pass me 1, print okay. So let's just see if that works. So if I don't pass a number, it's not happy. I've made a spelling mistake. Then it tells me what that number was. Okay, fine. So now we just need to do the bit of code that will work out the Fibonacci series. So a equals 0, that's the first item in the Fibonacci series. Then we've got 1 for I in range. We only need to go up to num minus 1 because we've already got a couple of the first couple of values there in A and B. So C is A plus B, and then we make C the new B and B the new A, so that we're actually kind of moving along this series of numbers as we go. So A comma B gets swapped with that, B comma C. But this is not new to you if you've looked at some of the other tutorials. So Fibonacci of num is C. Save that. So now if I do the same thing again, it's going to give me the Fibonacci of 10 to 55. Okay. So now I need to make a new another program which is going to do the same thing but a different way. So let's just copy paste that bit. Close that now actually. Okay, so just need to save this. So I'm going to call this fib_recur. Oops, I've called it fib_recut. Never mind, it'll still work. Okay, so I'll call it that in my comment because I can easily change that in a moment. So it uses command line arguments. And a recursive function. So that's the same. Then we need to define a function that's going to do the work for us, so we'll call it fib. It's a bit easier to type. So if n is less than 2, we can return n, because Fibonacci of 0 and 1 are 0 and 1, so they're the same. We don't need to do anything with them. If it's not the case, though, we need to return fib of n minus 1. Let's put some spaces in there. That's, oh dear, what am I doing? Plus fib n minus 2. So you might be able to see already where some of the inefficiency comes in there. For instance, if you're working out Fibonacci of 3, as it runs through that, this side is going to be asking it to calculate the Fibonacci of 2, and that is going to be asking it to calculate the Fibonacci of 1. Fibonacci of 2 will then come back through again and ask for the Fibonacci of 1 and the Fibonacci of 0. So every time we run through this loop, we're multiplying these calls, calculating the other numbers. You can draw it out in a really big tree if you want, which shows you exactly how quickly this gets very big. I'm not too worried about that here, because I just want to show you the real result in terms of the time it takes the program to run. But the theory behind it is quite interesting as well. So, I need to call my function. Actually, I don't think I need the brackets there. Fib n. Oh no, sorry, num. Okay. Save that. Hopefully that works. So I want to call fib recut of 10. So it works. Okay, good. Now, what I really wanted to do was, as I said, was to show you some of the differences that happen when you use these two different algorithms. So what I'm going to do is I'm going to say time pi fib recut 10. So that's taking 0.59 of a second. And if I do it the iterative way, .59 of a second. So it seems to be taking exactly the same amount of time, which is interesting. If I do the iterative way on 20, it takes 0.59 seconds. Interesting. Not really what I expected, but there you go. Recut of 20, 0.69 seconds. Looking a little bit slow there. Let's try 30. So now we can see that big jump in time. It's taking 1.496 seconds to do that in a recursive way. If I do it iteratively, 0.060. So the iterative method is still going very, very fast. The recursive method is very slow. When you get it increases exponentially. So if I try it on 55, I think you'll notice the difference even more. So to calculate the Fibonacci of 35 using a recursive algorithm, it's obviously quite expensive. I did actually try and do a video a minute ago where I did it with 50, but it took too long. So that's taking 15.322 seconds. So I just wanted to show you that really. It's just a couple of things really, using the command line arguments, which is quite fun, and also just illustrating how those recursive algorithms really do become expensive when you're doing some bigger numbers. Okay, thanks very much, bye.